Okay, integration by substitution. So you asked if it's integration and then you substitute in numbers. No. Yes. We're not substituting in numbers. We're substituting in like things. So we had the chain rule, right? So when you did the derivative of, let's say if I did dx of x squared plus 2x plus 4 cubed. Okay, so you would have told me that was what? 3 times x squared plus 2x plus 4 times 2x plus 2. Oh, I forgot to put this a second. Yes? Yeah. Okay, so we did that. So now when we integrate, we go from here, we went from here to here. Now we're going to go from where? There to there. So we have to have a method to deal with that. Make sense? Yeah. Okay, so we're going to deal with it. So our method that we're going to use is when we have the integral of f of x, g of x, g prime of x, dx. Okay, so we know that f is the outside function, right? And g of x is the inside. So we're going to have to train our brain to see that. Does that make sense? We're going to let, I guess I should have made this is, it's anti-differentiation of composite functions. It's a big thing. We're going to let g of x equal u. So du means derivative of u. Yes? Du. So it's g prime of x dx. So if I look at this, I'm going to replace g prime dx with du, and I'm going to replace g of x with u. So my new formula I'm going to use is the integral of f of u du is equal to the antiderivative of f gx plus c.
Where'd you get the c from?
When we take integral, you always have the plus c.
Oh, yeah.
Because it can be any constant. So this is what we are going to do. Okay? They say by substitution, and then they say changing variable, and they're kind of the same thing. We just change it twice on the change of variable. Okay, so I'm going to move this up. You good?
Yeah.
Okay. So now we just have a bunch of examples to train our brain. So I have the integral of x squared plus 1 squared times 2x dx. Now, if we took the derivative, this 2x we wouldn't put in the back, we'd put it in the front, yes?
Yeah.
Okay, but they just have it like this. So the first thing we need to do is, what is u? So remember, u was g of x. So what is u?
The inside.
The inside. So u is x squared plus 1. So that would make u prime what?
2x.
2x. Oh, sorry. U prime is the same as du. Or you guys want, I'm going to write du.
This is what I was doing, the one thing you taught me.
Mm-hmm. So du is the same as u prime, which is, and you do of this, don't worry about this, which is 2x. Following what's going on.
Yeah.
Okay. So, what did I want to say?
What do you do with the other 2x?
This is just, we're piecing this up yet. We haven't done anything. We're identifying. Because when we take the derivative, remember we take the derivative of the outside times the derivative of the inside. So we're trying to identify the derivative, what the inside is and what the derivative is. Because things will be missing because they simplified out. So we have to put them back in. Okay, so we have, this right here would be f of g of x times g prime of x, correct? If I use the chain rule?
Yeah.
Okay, so do I have g of x? Yes.
Yes.
Do I have g prime of x?
Yes.
Because g prime of x is the du?
Yep.
Okay, so now what I have is the integral of f of u du. So all I need to do is take the antiderivative. Oh, sorry, I meant to write u squared. So all I need to do is take the antiderivative of u squared now. Because I had everything else covered, correct?
Yeah.
So what's the antiderivative of u squared? This is side work. It's not equal to. Like when I write this equal to, it's not. Does that make sense?
Yeah.
Okay, so what's the antiderivative of u squared?
Oh, u squared or u?
Just did it last week, guys.
U to the cubed over.
So 1/3 u cubed plus c. Okay? But now we need to substitute back in the u, because that wasn't in the original problem, was it?
No.
So what is u?
X squared plus 1.
So we have 1/3 x squared plus 1 plus c. Oh, I forgot my cube, didn't I?
Yeah.
And I'm going to start writing this so it's not that close, because this is just side work. Does that make sense? Now, you'll do this hopefully enough that you don't have to do all this, but this is, when we do by parts, you'll have to do that anyway. Okay, so let's do another one. The integral of 5, the cosine of 5x.
So, we don't have to find anything for c,
No, c is,
but eventually we'll have to
if I
find-
give you a point,
Okay.
then you would put in, because this is f of x, right?
Yeah.
So if they give me a point, I would put in my x and my y and find c. Okay. 5x dx. Now this is how they have it written. What is missing that we normally put in there? Parentheses. Should we put those parentheses in there?
Yes.
Because once you do that, do you see the inside and the outside?
Yeah.
Okay. So u is what? Use that inside.
What is 5x?
5x. So du which is u prime, is what?
5.
5. So, do we have 5 covered here? Yes? So all I need to worry about
Let's go second.
is the integral of cosine of u du. So what is the integral of cosine?
Negative sign.
Sine.
Oh, I switched.
Yep,
my
you
negative
switch
all the
it
time.
because if it's the derivative of cosine is negative sine. So
That says and.
so it's sine of u plus c. So f of x equals the sine of what?
5x
5x
plus c.
plus c.
So, like, we didn't have to do the 5 because it, like,
Because the
equals
5
prime equals 5, like,
Right,
cancels out.
because f of g of x, g prime of x. So this was g prime of x,
Uh-huh.
and this is my g. So it's there,
Okay.
okay? Now we'll, in the next one, we'll have to take care of if it's not there or if there's extra things there, stuff like that. But these were just, everything was there.
Okay.
And again, this is just side work. It is not part of the integral process. Okay, so it's recognizing the u, the f, all that kind of stuff. I don't think Okay, so now I have the integral of x squared plus 1 squared dx. So what is u?
X squared plus 1.
X squared plus 1. So what is u prime?
2x.
2x. What's missing?
Do we need to bring that square over to the x in the front? So then it's both 2x?
Well, we don't bring it over, but so this right here should be f of g, or f prime of g, g prime. Yes?
Yeah.
Okay, so what's missing?
D.
The 2. Isn't the 2 missing? Is there a 2 anywhere here?
No.
No. So where did the 2 go?
No.
How did the 2 go to 1?
Derivative?
No. How do I make any number 1?
Subtract.
No.
Technically.
Divide by itself, yes? So if there was a 1/2 out in here, would this end up to be 2? I mean, just 1? So we got to put a 1/2 in front of here. Okay. The integral of u squared. Now, you can put u prime or you can put du. I kind of switch back and forth because isn't u prime the same as du?
Yeah.
Okay. So once I put that 1/2 there, does it take care of that missing 2?
Yep.
We good? Okay. So, integral. So I get 1/2. What's the integral of u squared?
X squared plus 1. Squared.
No, what's the integral of x squared, u squared? Add 1, divide.
1/3.
1/3
U to
u to the third. Plus c. Okay. Well, 1/2, 1/3 is 1/6. And u is
X squared plus 1.
x squared plus 1 cubed plus c. So you have to think, you were thinking backwards the whole time. Where did the 2 go? It was multiplied by half.
Yeah, I think the only thing that's gonna confuse me is when there's like this problem and it doesn't, like we're missing the 2.
So if you're missing something, you're going to have to multiply by its reciprocal, yes? What if something was added in? Then you'd be multiplying by, so you have to think about that. It's like there. Okay, the integral of okay. This is called change a variable. It's really basically the same. I hate that they give me a different name. So the square root of 2x, minus 1 dx.
We should change that to 2x minus 1 to 1/2. Prime 1/2.
Okay, we will, yes. So what is u?
2x minus 1.
2x minus 1. And u prime, which is the same as du, correct?
Yeah. 2.
Would be 2. Okay. So we're missing a 2 because I don't see any 2 out here, do you?
No.
So what was it multiplied by?
1/2.
1/2. So I have 1/2 integral of u to the 1/2 du. And that's what you were saying, Ainsley, correct? Okay.
I don't like when they're squared. It throws me off.
Mean square root.
Yeah, doing it to the 1/2.
Oh.
Or
Okay, so we have to add 1. So if I add 1 to 1/2, you get what?
3/2.
3/2. So I have u to the 3/2. And then I have to divide, so multiply by 2/3 plus c. So 1/3 and what's u?
U is 2x minus 1.
To the 3/2 plus c. So
Wait, why is it 1/3? Because you added 1.
because you these two.
Okay. Oh, I thought it was.
We added 1 and multiplied by the reciprocal, but then when you take 1/2 of 2/3, you get 1/3. So they say it's, I mean, if you look in here, it's like change a variable. Well, we're already changing variables, yes? Now, I changed variables at the very beginning. They did not. I think it's easier to look at. Make it simpler. Once I put that u in there, doesn't it make this problem much easier to look at?
Yeah.
Yeah. Okay. What?
Don't change it. I'm still reading.
Now this is a true change in variables. Okay, so I have the integral of x, the square root of 2x minus 1 dx. Is that similar to what we just did?
Yes.
Yeah? Okay. But it's going to be different. Okay, so what's u?
2x minus 1.
2x minus 1. And what's du?
2.
Okay, so we have to account for everything up here, yes? So I've taken care of this. I know where that went multiplied by a half, can't talk, right?
Yes.
So we have 1/2 the integral. But what do we have here?
An x.
An x. We can't have u's and x's over here, can we?
No.
We only can have u's. If we have u's, we have to have u's. If we have x's, we have to have x's. So we need to solve and get that x in terms of u. Well, do we have an equation that we could do that in?
2x minus 1.
2x. I have u equals 2x minus 1, right?
Yeah.
So if I was going to solve that for x, I would add 1 and divide by 2. So x equals u plus 1 over 2. So I'm going to substitute it back in then. So x was what?
U plus 1 over 2.
So I have u plus 1 over 2. U to the 1/2 du. Okay, well that looks gross, yes?
Yes.
Okay, so, well, this 2, can't I bring out another half? This 2 right here, can I bring out another half?
Yeah.
So that would be 1/4. The integral of u plus 1 times u to the 1/2 du. Looks a little better, right?
Yeah.
Now could I make it even better by distributing that? So I would have 1/4 the integral of u to the
Wouldn't it be to the 1/4? Or
when you multiply you add, so that'd be 1 plus 1/2 is 3/2 plus u to the 1/2 du. Now that was truly changing variable because I changed the x to a u, didn't I? Okay, now I just integrate. All that to prep to integrate. But again, think about having to integrate this. No. Okay, so we have 1/4. So add 1 would give me what?
2.
No, add 1 to 3/2.
It would be
5/2. Multiply by the
reciprocal.
reciprocal. And then add 1 to 1/2, which will give you 3/2. And then multiply by the reciprocal. Do you see how I write the exponent first and then come back? Because if I can see the exponent, is it easier to reciprocate?
Yes.
Yes. Plus c. Now there's a couple different ways we could do this. I personally, if I'm going to have to do math with it, I would factor out 2/15. Okay, the 2 is from the numerator, yes?
Yeah.
The 15th is because that is the least common denominator. Okay, if I was going to have to do more math with it. Okay, if I don't have to do more math with it, they distribute the 1/4 in. Okay, I don't really care. I always try to leave it the way I would leave it if I had to do more math with it, personally.
I feel like that would be messy because we'd have to find a common denominator with all 3 of them.
Well, you only have to do with these 2.
Oh, they don't have to be the same?
These 2 have to, like if I'm factoring it out to make it nice, we're going to do both. Okay?
Okay.
So 3 and 5 with 15 would be the common denominator, yes? And I'm going to factor out the 2 because there's a 2 on it, both, correct? So if I'll have 1/4 times 2/15. So if I'm factoring out, I multiply by the reciprocal, yes?
Yeah.
So the 2/15 times 2/5 would give me 3. And u to the 5/2. And we'll have to substitute that back in a second. Plus, so if I factor out the 2/15 of 2/3, multiply by the reciprocal, that would leave me 5 u to the 3/2 plus c. So,
How did it say?
because when I divide by 2/15, I multiply by 15/2. So 5 goes into 15/3. Okay.
That makes more sense.
So this would be nice and give me what, 1/30? 1/30 of 3, 2x minus 1 to the 5/2 plus 5 times 2x minus 1 to the 3/2 plus c. Okay. Now, if I just distributed the 1/4 in, I'm just going to distribute 1/4 to 2/5 and 1/4 to 2/3. Ready? That would give me 1/10 u to the 5/2 plus 1/6, right? U to the 3/2 plus c, which would have 1/10 2x minus 1 to the 5/2 plus 1/6 2x minus 1 to the 3/2 plus c. You personally have to decide which one you would like to do math with better. I would like to do math with this one. Why do you think I like this one?
The other one's messy.
The other one's messy because you have a fraction, yes?
Yeah.
I could even factor out, couldn't I factor out a u to the, 5/2?
Yeah.
Or, sorry, 3/2. A u to the 3/2. I could even factor that out if I wanted to. And I could make it 1/30 2x minus 1 to the 3/2. And then this would be 2/2, which would be 1, yes? So then it would be 6x minus 3. Well, you factored that out, plus 5, plus c. So this would just be, plus 2?
Yeah.
So 1/30, I'll move it up in a second. And 2x minus 1 to the 3/2 times 6x plus 2 plus c. Now, if I'm going to have to do math with this later on, I'm picking this one.
Yeah.
Because we've cleaned it up, haven't we? Now, I'm going to tell you this is what you would find in the back of the book. But which one of those is cleaner and you'd like to use? This one. Especially if I had to plug in X and Y, wouldn't this one be much nicer to plug it into?
Yeah.
Yeah. So knowing how to simplify can make my life easier in the end, can't it? We got a cosine sine one. How about that one? We probably should do that, shouldn't we? Okay, this will be our last example for today. The integral of sine squared, and I'm going to put automatically 3 parentheses in there. The book does not have your parentheses. Guys, put them in. Can you imagine doing this problem without it?
I'd accidentally mix them up and put the wrong thing.
You'd put like X by itself or some weird thing like that, right? Your brain, like, we need those.
My brain doesn't work on its own, so.
Okay, so remember that this really is sine of 3x squared, yes?
Yeah.
Okay, so u would be 3x. So du, which is equal to u prime, would be 3. Oh, no. Nope. I messed that up. Let's rewrite this so we can see it. And I know why I just messed it up. I said it and then I didn't see it. Okay, so this is really sine of 3x squared. Yes? So what is u then? Sine of 3x. See what? We said it, didn't we?
Yeah.
But then we didn't do it. Okay, so if sine, so that means du u prime is what? Cosine of 3x. But wouldn't we also have to do, like if we were doing this, we would have to take this, and we still have to take care of what? The 3. Because if we were doing the chain rule, we have to do the outside, the inside, the inside. There's 3 functions there, isn't there? So we're still missing a 3 somewhere, aren't we?
Yeah.
So then we need a what? A 1/3?
1/3, yes.
Okay, again, why do we need the 1/3? Because we're missing that 3, aren't we?
Get the 3. Yeah.
Okay, so if with that 1/3, we've taken care of the 3 that should be there, yes?
Mm-hmm.
So now we can just say u to the second?
Yeah.
du? Okay. So the integral of u squared is
Sine squared.
no, we're u squared.
Oh yeah. It's 3 or 2.
Add 1, divide. 1/3 u cubed.
Yeah.
Okay, sir.
I'm confusing myself now.
Yep. Just once we've replaced this, don't think about those yet. Don't think about those. Okay? You all know where 1/3 u cubed comes from. Yes? Okay. So now we've got 1/9. And we substitute back in u. What's u?
Sine 3x.
Sine of 3x. So we have sine cubed of 3x plus c. So where'd this 1/3 come from?
To try to.
Because
The
we
three
would have had to
missing.
take the derivative of that too, correct?
Yeah.
And I don't really know how to write that with another variable. Like, I can't use u double prime. Oh, actually, I should have done it this way. If u is this, yes? So the derivative of this would be cosine of 3x times 3. There you go. It should be right there. Shouldn't it be there? Because we did the chain rule again. Okay, so there's why that 1/3 is, because we're missing that 3, aren't we? I needed to write it somewhere. Ainsley, what's wrong?
Oh, my head's killing me.
Oh, okay. My sinuses are too really bad.
My sinuses, my stomach hurts, my head hurts.
You're just a mess today.
Yeah, I feel like I could puke.
Okay, so today we're doing 5 through 18. Okay, it's 14 problems. Do we know why we need 14 problems? Practice. And I took away on the computer. You can look at them. But I'm not doing that. I think we lose something. We as in general, I don't think we've quite learned that when I sign it on the computer, we still have to completely do it on paper. I think we lost, you know what I mean? When I assigned them on the computer, I think we lost some of that. Mm-hmm. And I think that was kind of our disconnect with derivatives and things. I like the computer assignments, but I don't think you guys are getting it as well. Does that make sense?
The ones where we enter it and
yes.
It tells us, okay.
Yeah, I think that's why you can still use your online book, but I'm not assigning them through WebAssign because I think we lost. We weren't making a connection with actually physically doing every single step. Does that make sense?
Yeah.
Okay, so 1 through 18 today. We'll dive more deeper tomorrow because we'll have general power rule and things like that. Got it?
Yep.
Okay, tomorrow if we have to go through a ton of like fixing whatever, we will. But I want all those done, guys. Got me?
Yep.
Okay.
Is it on Classroom?
Yes.